Hello, microeconomics students. This chapter, chapter 21, is a very challenging one in terms of the calculations and the new information presented. So my advice to you is going to be, of course, read the chapter and go through the PowerPoint first, take notes, make sure you understand just the general concepts, and then I'm going to help you work through portion of the homework problems, give you some guidance as to how to approach them. And so I think you'll get a deeper understanding of this if you approach it that way. So I have a few homework problems here, and I'm going to just go through the setup and some of the solutions so you can see how to proceed. Number one is asking you to recognize these different concepts of cost, specifically marginal cost, average fixed cost, average variable cost, average total cost. If you haven't read the chapter and gone through the material, this will just be really indecipherable for you. So my strong advice is go in, read, do the best you can to understand the concepts first, then come back and try to apply them through the homework. So here we go. We've got marginal cost and these measures of per unit cost. So when we're talking about marginal and averages, we're looking at per unit costs, and as a marginal decision maker, the firm is interested in what the per unit costs of producing a single unit are. And that has to do with pricing and with quantity output decisions. So in this case, you're just asked to do some calculations, but you're going to want to know how to do that. And they give you some total cost information, and your job is to work a little bit like a detective here and go in and work backwards in some cases. So you're going to need a good understanding of what these are before you proceed. So let me walk you through this. If we have 0 produced, but we have a total cost of 600, that is some information that we want. What that means is our fixed cost, not our average fixed cost, but our total fixed cost is $600. Because if we produce nothing, but we have a fixed cost or a total cost of 600, we know we have fixed cost of 600. And that's going to be a starting point. Now this is asking us for averages. So the average fixed cost is the fixed cost divided by the quantity output. And so we can see the rate of output, we can see the fixed cost, so we can do a little bit here. So we can start with the average fixed cost column. So to produce 600 divided by 1, then we go 600 divided by 2, because we're just doing the average column, 600 divided by 3, and so on and so forth. Okay, I'll let you continue with that. From that, we can get some good information, and we can figure out average total cost because we've got the total cost. So let's do that column next. And average total cost is a lot like the average fixed cost. It's going to be total cost divided by the quantity of output. So we're averaging that cost over the quantities of output. So our average total cost for 1 is 800. Clean that up a little bit. For 2, it's going to be our total cost divided by our output. So it's 1,050 divided by 2, so it's going to be 525. 1,400 divided by 3, and so on and so forth. So that's how you're going to do your average total cost. So pretty manageable so far. The next one that becomes really simple to do now is average variable cost, because here's a formula to work with. We know that average total cost is equal to average fixed cost plus average variable cost. So since we know that, we can go ahead and figure out that average variable cost is the difference between average total and average fixed. So in this case, our average variable cost is going to be 200, and that's actually our total variable cost, but it's divided by 1. Our next average variable cost, well, it's the difference between average fixed and average total. And so in this case, we can see really easily that it's 225, and we'll continue the same way. So we're just finding this value here as the difference between average total and average fixed. So pretty manageable. And then the last one, marginal cost. It's tempting to think of marginal cost as the same or in the same way as variable cost. And it is not. It is a separate calculation. Marginal means additional. And so the formula for calculating marginal is, I'll write it over here, it's the change in total cost divided by the change in output or quantity output. So marginal cost in this column right here is going to be that change in total cost divided by the change in quantity output. Now the good news for us is the rate of output is always changing by 1. So we really don't have to do much beyond find the change in total cost. And that just becomes the distance between these values. So a little simpler than it might seem at first. So we've got marginal cost here of 200. It's the change in total cost divided by 1, the change in output. The next one is going to be the difference between 1,050 and 800. So our marginal cost is 250 because it's the change in total cost divided by the change in output, which is 1 again. And we're going to continue the same way. And you can see that the next one's going to be 350. Right, it's the change in total cost. And it gets easier from here. And you see that to 1800, the change in total cost is 400, and so on and so forth. So filling this out becomes a little more manageable once you know what the formulas are and what each column represents. But I really do not recommend that you approach this blindly, not knowing what these terms mean. It will make you a little bit crazy, I think. All right, continuing on this one. Now we're going to graph some information. And it says they give you some tools to use here. Hopefully those are working for you in Connect. And we're going to draw average total cost curve and a marginal cost curve. And we're going to plot 5 points for each curve. And those 5 points can be found right here in the chart. So we're going to plot those on the graph. And I'll just show you the beginnings of each one of them. So for that first unit, let's do the average total cost curve first. Okay, so we're going to plot rate of output, which is going to be on this lower, this horizontal axis. And then we're going to put our average total costs on the vertical axis here. And we can just see pretty easily how this is going to work. So going to that chart, that first unit of output has an average total cost of $800. So it's going to go like this. 1 unit of output, $800. There it is. Oops, I missed it by a little bit, but you get the idea. The second unit of output has an average total cost of $525. 525, and hopefully I get the spot right. And, oops, didn't mean to do that. And we're going to continue on. Let's see if it'll let me do it this time. 525. There. Doesn't want to talk to me. Well, hopefully you're seeing the general idea here. And so you're going to plot 5 points on that curve. So as you finish the numbers here, you're going to plot them on this graph. The other graph, on the same graph, the other curve you're going to plot is the marginal cost curve. And you do it the same way. You read rate of output on the horizontal axis, and you plot those marginal costs on the vertical. So let me change colors and see if I can show you how that one's going to be different. And let's see, let's go here. Let's see what happens here. So that first rate of output is going to give us marginal cost of 200. So that first unit of output, I should have said. So here we go. Here's my marginal cost of 200. Then I'm going to go to my second point. My second unit of output has marginal cost of 250. And so we're going to go 250. And I think you see how it becomes pretty easy to do this now. The third unit of output is going to give us 350 in cost, in marginal cost, I should say. And so on and so forth. I would recommend you just keep track of these, do them one at a time. If you plot all those points together, it becomes a mess that you can't really see. But if you do it one at a time, and I noticed that in the tool here, they give you different colors to work with, so that will help. And then the last part of this one, after you've graphed those two curves, is they ask you at what output rate is average total cost minimized. And you're going to be able to see that in this column here. You won't need to see it graphically because there's going to be some number here, and I didn't calculate all of these numbers for you, but you can do it very easily, and you're going to have a point at which it hits a minimum. So, and I don't know what that one is offhand, but you'll be able to see it numerically very, very easily. All right, so that's one, and I think that's a good start to what I'm asking you to know in this chapter, what the book is asking you to know anyway. So 2 gives you a chance to practice that again. So I would use that same method and just go back through and calculate each column, understanding what those numbers represent. All right, so number 3 then is asking you something about economic costs and accounting costs. Again, I'll go through the material, make sure you understand the concepts, and then this application becomes pretty simple. So in this case, suppose that a company incurs the following costs, and they give you labor, equipment, and materials. The company owns the building, so it doesn't have to pay the usual $700 in rent. So accounting costs. Accounting costs are those costs that you would literally take to your accountant at the end of the year and show them receipts for, and they are what we call explicit costs. So we can see that labor would be an explicit cost, and equipment, definitely we'd have explicit costs, and materials that we purchase. So our total accounting costs, these explicit costs, are going to be $1,100. The total economic cost is implicit plus the explicit. So we've already got the explicit at $1,100. The trick now is to find the implicit cost, what we would call opportunity costs in economics, and that's going to be the $700 in rent that we're foregoing, because if we weren't renting the building ourselves to use it for our business, we would rent that out. So it's an imputed cost, and we call that an implicit or opportunity cost of running the business. So in this case, the total economic cost then is the implicit plus the explicit, so it's going to be our $1,100 plus $700, $1,800. Finally, if the company sold the building and leased it back, what would be the change in accounting costs? So instead of having that as an opportunity cost, that $700 in rent, if we're leasing it back for the business, then we're now paying $700 in rent, and that becomes an explicit cost. So our accounting costs would now be $1,800, and our economic costs would be the same. They'd be $1,800. There's no implicit cost anymore. It's an explicit cost now. So the change in accounting costs, I've got to be careful about the wording here. The change in accounting costs is $700, right? It goes from $1,100 to $1,800, so it's a positive $700. And the change in economic costs, notice that it's the same value, so no change there. So this one's not too bad as far as calculations go, but you're going to want to know the concepts of accounting costs and economic costs. All right, the next one is going to ask you to know yet another concept that's pretty challenging, so make sure you're comfortable with the idea of marginal physical product. Marginal in economics means additional, and we, as businesses, are really interested in marginal costs because we want to be precise in our decision making. And if you remember our definition of decision making, marginal decision making, it means that we take incremental steps and reevaluate the costs and benefits at each step. That means that we're making the most precise decisions about how much to produce, and we can stop at the moment when the costs of production exceed the benefits or the price. So all of this matters, and the marginal decision making as far as how much to produce is an especially important one, because businesses don't just randomly produce a certain amount. They do it strategically using marginal decision making. And so let's start at the top here. This one goes all the way. This is a pretty elaborate question. It has many parts to it, and I'm going to let you work through number 6 on your own, but I'm going to give you some ways to get started on this one. It's not as bad as it seems. It's just the matter of interpreting the question, finding the information you're looking for, and then using it appropriately. So this gives us a table of jeans and the labor input, jeans production, and the labor input versus the capital input. And in this case, our capital input is sewing machines. And it tells us that we're supposed to imagine that a firm has 2 sewing machines. and can only vary the amount of labor input. So here's what we're going to do. We're going to go to this chart and we're going to say, okay, with 2 sewing machines, given varying inputs of labor, which is measured up here, we can see what the production possibilities are for this firm. And it says graph the production function. So the production function is the relationship between inputs and outputs. So in this case, we've got 2 sewing machines and varying amounts of labor, and the output is what can be produced. So we're going to graph this production function, and you'll see that it's actually a pretty simple thing to do. So look at the graph, and here we have our labor input, because that's what's varying here. And this is, we're looking at how many pairs of jeans can be produced, given those 2 sewing machines and then these varied amounts of labor. So we're just going to go with the numbers from the chart. It's actually really simple here. We're going to say with 1 worker and those 2 sewing machines, 20 pair of jeans can be produced. So 1 labor input, and here's 20 pair of jeans. Now this is going to be harder for me to pinpoint it, but I think you can see how to do this on your own graph. You'll have a tool that works way better than mine. Okay, so 1 worker can produce 20 pair of jeans. 2 workers can produce 46 pair of jeans, going back to that graph. So we're going to come up here, 2 workers, 46 pair, and you're going to find that very precise spot on your graph. And you start to see it's pretty easy to plot these points. With 3 workers, again, the same amount of capital input. The sewing machines doesn't change. So with 3 workers, 64 pair can be produced. And we'll come up here and we'll put that in at 64. This program doesn't like me to tap it. This 4th worker brings us 72 pair of jeans, and this is our total product, right? The 4th worker, 72, and our 5th worker, 78 pair of jeans, and you're starting to see how this is going to work. Our 5th worker gives us, let's see, did I get my 4th worker? 72, I kind of marked it there. My 5th worker, I already forgot the number. See how that works. Oh, 78. 5th worker, 78. And I think you can work ahead of me and start to see this. And then we have 82, and it falls to 80. So you're going to get, and I'm just going to sketch this because I'm not going to make it perfect, but you'll see that at some point that curve flattens and starts to head down. So once we've graphed it, then the question becomes, about analysis. What have we got here? What does this total production or this production function tell us about marginal product? Because remember, this is all about that marginal decision making. So total product is a portion of what we need to know, but really we're looking for what each additional employee brings us in productivity. So for B, we're going to compute and graph the marginal physical product. So we've graphed in part A the production function, and now we're going to graph the marginal, and we're going to pull out that information. So here we go. We're going to first calculate the marginal. How much do we get for each additional worker? So marginal simply means additional, and it's going to be the change in output divided by the change in labor, similar to what we calculated before with marginal cost. So it's the change in output divided by the change in input. In this case, the variable input is labor. And the good news, just like before, is that the change in labor is always 1. So all we really have to do is find the change in output to get our answers. So for that first worker, well, with no workers, we produce 0. So our marginal output with that first worker is 20. We get a total change of output of 20 and 1 worker, right? 20 divided by 1. Then we have a change in total is 20 to 46 divided by 1 again, because from 1 to 2. So we've got 26 marginal. And then from 46 to 64, we've got 18, and so on and so forth. 64 to 72 then is 8, and 72 to 78 is 6, to 81 is 3, 81 to 82, and then notice that you've got a special situation here. It goes from 82 to 80, that's a -2. And make sure they remind you about that negative sign, but watch out for that, because you actually have what we call negative marginal product there. And now we're going to graph it. And this is, again, pretty manageable once we've got the numbers worked out up here. So our marginal physical product is a relationship between the labor input on the horizontal axis and the marginal productivity per day of each additional worker. So here we go. That first worker brings us a marginal 20 pair of jeans, right? So there we go. The second worker brings us a marginal 26 pair of jeans. So there we go. The third worker gives us a marginal 18 pair. The fourth worker gives us a marginal 8. The fifth worker, a marginal 6. And this is all in the positives. They have the negatives down here because of that last number, but make sure you're working in the positives here. Our sixth worker brings us an additional 3. So we're going to carefully plot that right there. Our seventh worker gives us 1 marginal. And then our eighth worker costs us 2. So we're going to put that down below 0. And I don't know if the tool smooths this out at all, but you're going to have basically this is your marginal product curve. So notice that it's, well, I don't know if you notice this, but here's your total product curve. The marginal curve represents the rate of change along the total product curve. And so in math terms, it'd be the first derivative, but don't let that scare you. We're not going to do calculus here, but it's the rate of change along that total product line. C asks us just for some simple analysis. It says, at what amount of labor input does the law of diminishing returns first become apparent in our table of marginal physical product? Well, diminishing marginal returns. We get less as we continue on and produce more units. So we can see it pretty easily right here. From 20 to 26, we get increasing returns. However, from 26 to 18, that marginal, right, we have diminishing marginal returns. So with that third unit of output, we start to experience diminishing marginal returns. And you'll notice that it continues to diminish. And it matches up with our graph. We have increasing marginal returns, then we have diminishing, and then at 0, we actually enter into negative marginal returns. So we start to experience them at 3 units of output. Is total output still increasing when marginal physical product begins to diminish? And this is a tough one. Total output is still increasing. So it's tempting to look at this marginal curve and say, oh, it's all just downhill from there. No, it's actually that the marginal amount is decreasing. However, it's still a positive number. So let's go up to the chart to see if you can see that a little more clearly here. I'm still getting positive additions to my marginal productivity. It's just that I'm getting it in smaller and smaller amounts. That's why we call this diminishing. It's not negative. It's not cutting into my overall productivity until I get to the negatives. And the negatives are, down here you can see that I would never want to produce that amount because it actually costs me productivity. But up to the point where it goes negative, with each additional worker, I am getting more product. Right? I'm getting, with my 6th worker, I'm still getting 81. So it's still 3 more than 78. With my 7th worker, I'm still getting 1 more. So all of these are positive additions to my total physical product. It's just I'm getting them in decreasing amounts. So that's kind of a tricky thing, and I would advise that you kind of go over that concept because it's an important one in recognizing what we're looking at here, this diminishing marginal returns. It has to do with the decision making of firms and how much they're going to produce. And so they consider the point of diminishing marginal returns, but that is not necessarily where they stop. But they recognize that there's diminishing, there's negative, There's increasing. And I said that out of order, so let me just be a little more clear. Increasing, diminishing, negative. And so in this range, it's still a positive addition to the total product. If you think of this as a pile of product, you're still adding to the pile, just at a diminishing rate. And then what is the value of marginal physical product when output no longer increases? And we've got it right here. We already identified that in the chart as -2. Because we're not getting any more increases, right? We're going from 82 to 80. So when we're no longer getting any increases, marginal physical product is -2. So that is a tough one, and I strongly encourage you to go to the next one, number 6, and work through it and see how you do with it. But follow the same pattern and path of logic there, and it should give you a good chance to practice it. Number 7 deals with the average total costs of different firms of different sizes producing varying quantities. So what you have here is a small, a medium, and a large firm, and the rate of output and their average total costs at the different rates of output. And so what they're asking you to do is just actually some simple matching up of things. So for A, they say which curve in the graph below represents the average total cost for the large firm. Well, you can go to curve, the different curves, and you can see what the large firm is. So the large firm has at 10 units, 1,000. You can just kind of see where they are, and it's pretty obvious that it's curve C, and you can just see it really easily. So large firm is 1,000, then at 20 units, 900, and you can just logic that one out pretty easily. So the large firm average total costs is going to be curve C. I don't know if yours will appear differently. I know there's an algorithm version of this, so if you get a different one, use the same understanding of that. B says which plants should be used to produce 40 units. So we can come back up here and we can go to 40 units and see what the costs are, produce 40 units, and who can do it the cheapest, and it becomes really easy to say, oh, okay, it's the medium firm. They can do it at the lowest cost. Right? So again, super basic here. For C, a little bit more challenging. They say which plant should be used to produce 100 units. And so we can see here that right off the bat, you look at it, you're like, okay, well, a large firm can produce 100 units for the least of these three options, but there is something else to consider. If you go to 50 units, and so you wouldn't necessarily see this right off the bat, but I want you to just consider some different options. If you go to 50 units, notice that the medium firm can produce 50 units for $200. So if you have two medium-sized firms producing 50 units each, there's your 100 units at a total cost of $400. So 400, of course, is less than 500. Therefore, your best answer here is 2 medium plants. And you might go through, if you hadn't come to that on your own, you might go through your different options and calculate what the costs are. But don't go immediately to the first super easy answer, because there is a better answer there. So watch out for that if you get another version of this. And then, do economies of scale exist anywhere in these plant size choices? And the answer is yes. And you can see economies of scale in the period of production where average total costs are coming down. So economies of scale can be seen as average total costs in the long run are coming down. So that's kind of a pretty straightforward one, that you can see those economies of scale. Number 8 is going to give you some productivity calculations, and this is going to go back to that concept of marginal physical product, and you're going to simply calculate what the different levels are. Let's see, here we go. So we've got our labor input, our quantity output, and we're going to calculate the marginal. Marginal is the change in quantity or output divided by the change in input. In this case, it's labor. And so the change in labor is 1 at every point, so it becomes a very simple matter of finding just simply the change in quantity output. So from 0 to 10 is 10. From 10 to 22 is 12, right? It's the difference between those two. From 22 to 30, is 8. From 30 to 36 is 6. 36 to 38 is 2. And then watch out here, because from 38 to 37 is actually a -1. This goes back to the concept of diminishing marginal productivity. And remember that as we get more of something, we get less additional productivity out of it. And so where did we start to get diminishing? Well, we have increasing from 10 to 12, but then we experience our diminishing when we go from 12 to 8. So with our third worker, we get diminishing marginal productivity. So that one's just a nice little practice of the concepts you've probably already seen and mastered. Number 10 gives you some information, asks you to answer some questions observing fixed inputs and variable inputs. So they give you this output scenario to produce 15 pair of jeans. You've got a factory, a sewing machine, an operator, and some denim. And they say which two inputs are most likely to be fixed in the short run. And fixed would mean not variable in the short run. So common sense, I think, says that in the short run, you're not going to be able to vary your machine capacity, sewing machines, and you're probably not going to be able to vary your factory. And we call factory plant. And that's one of the hardest things to change, especially in the short run. By definition, short run means you have at least one fixed input. And that fixed input is almost always the plant or the factory. The other two, operator and bolts of denim, are going to be more changeable. So for B, which two inputs are likely to be variable in the short run, that's going to be the fabrics used and, oops, sorry about that, not sewing machine, operator. The number of workers hired, that tends to be more changeable or elastic, to use a term we've used. And then finally, it asks us to calculate some costs. So the fixed costs per day can be calculated at our fixed inputs, right? The cost of our fixed inputs. Well, we said the factory and the sewing machine are fixed fixed costs. And so $100 a day for the factory, $20 a day for the sewing machine. So you have fixed input costs of $120 a day. Variable costs are going to be our two inputs that are variable. So our operator and our bolts of denim. And we said that we use 1.5 bolts of denim. So $125 for our variable inputs. Total cost is going to be those two together. So $245. And then the average total cost is going to be that total cost divided by the output that we're producing. And so this is 15 pairs of jeans. So we're going to go 15, 245, 15, and 2. This is, by the way, my third grade long division way of doing it. Another way to do that is, if you want to set it up, is 245 divided by 15. That's going to give us our average total cost. All right. And just by way of checking your work, because you're going to have another one to practice with, is 16.33. So there you go. That one, not so bad, but it's an important concept to make sure you practice. Let's see, 7. Let's go to the next one. 12 is another pretty straightforward one. I think you'll be just fine with it, but let me run you through. This one's a little bit like a number puzzle, and you're just going to fill in what you know. Now, this is not averages like that first one. This is going to be fixed cost, variable cost, total cost. An important piece of information here is going to be that fixed cost plus variable cost equals total cost. Just like average fixed plus average variable equals average total. So having that in mind gives you some good information. So for example, if you've got none produced but your total cost is 100, you know that your fixed cost is 100. And fixed cost means fixed cost, right? So it's 100 all the way down. Then it becomes super easy. If it's 100 and total cost is 100, variable cost is nothing. If we've got 100 of fixed and 40 in variable, total is 140. If we've got 100 and 100, total cost is 200. See how easy this is? if our fixed cost is 100 and our variable cost we don't know, but we know our total cost, we do some subtraction here. We've got variable 170, and here we're going to add these up. So this one, really, really basic. It's just really asking you to understand this concept, this equation. 14 takes us to another puzzle just like that. And instead of working through that one with you, I'll let you run through and sort that out. 15 is similar to a previous one where we're talking about explicit and implicit costs. This is that accounting profit versus economic profit, or accounting cost versus economic costs. So here we have some information. Kenesha has opened her coffee shop. She pays $5,000 in rent each month, and I would just kind of itemize these costs. $4,800 for payroll, so that's rent, payroll, and what you can see right off the bat is these are explicit costs. You would get a receipt for these. You would report these to your accountant. And $1,200 for supplies. She's planning on selling several of her own tables and chairs on Craigslist for $1,500, but instead she brought them to her shop. Additionally, she quit working as an accountant where she was earning $52,000 per year to open up the shop. So let's find her explicit and implicit costs. Well, her explicit costs are these three things: her payroll and her supplies. Her rent, her payroll, her supplies. So we can add this up, and, well, actually, they're not asking for that just yet, but payroll, supplies, and rent. Okay. We can see really easily that she did not lay out any cash for the table and chairs or for her accounting wages that she gave up. So those become her implicit costs. So the table and chairs, what she would have done with them if she didn't use them for her business was she would have sold them. So that becomes an implicit cost, and the accounting wages she gave up are an implicit cost of her choice to use her human capital for her business. So now we have implicit, explicit, and we can total these up now. Her accounting cost is going to be the total of her explicit. So that's going to be 11,000, I think. I'm not looking at the numbers here, but I'm pretty sure that's what it was. Oh, her total. These are monthly figures. Okay. Take this total, multiply it by 12. So this is her monthly explicit costs, 11,000 a month times 12 months in a year, and we get 132,000 accounting costs. And then her economic cost is going to be her accounting cost plus her implicit costs. So you have the 132,000 plus the 1,500. Hang on, let me put that in the right place. So plus the 1,500 plus the accounting wages she gave up. And so she would have earned $52,000 a year in accounting wages. So you can total it up and get her total costs over the course of the year at $185,500. So this one just really is asking you to recognize explicit, implicit costs and economic wages or profit versus accounting profit. All right, let's see. Did I miss one? Nope. All right. And the last one here is based on the idea of productivity, and it gives you hourly wages versus productivity in two countries, U.S. and China. And what you're going to want to know about this is how to calculate the productivity rate and the per unit labor cost. And so here's what you're going to want to know. You take your wage rate divided by the marginal physical product, right? That's the per worker product. And that's going to give you the productivity rate or the per unit labor costs. So for the United States, you'll just set this up. It's pretty basic here. In the United States, the wage rate is $24 an hour. And they are able to produce 20 units per hour. That's the marginal physical product for each additional worker. And so the 20 units per hour, and you get a per unit labor costs. So that's the U.S. Then you're going to set up the same information for China, and you've got the wage rate is $3 an hour, and they produce 4 units per hour. And that's going to give you per unit labor costs in China. And it might surprise you to discover that one country has a lower cost of productivity than the other. And then finally, if a company's goal is to minimize per labor costs, which one's going to be lower? And I think you'll figure that out pretty easily. All right. So this chapter is manageable, but again, I advise you to read through the material, take notes, learn what you can before attempting the homework, and start early in the week. I'm going to have this posted pretty early in the week, and so take advantage of that. Get started early. You don't want to find yourself in a panic at the end of the week trying to understand something really complex and feeling the pressure. So give yourself lots of time, and I wish you lots of luck with this.